So dear participants, let's resume with our lecture on output devices that can be connected to a PLC. I will not take much time with this particular part because now you have understood one thing, that PLCs, they actually give you the output in the form of a digital signal. Okay, either it is low or high. Now that digital signal can be applied to any actuator that you can think about. It can be a simple pilot lamp, it can be a simple LED, it can be a piezoelectric buzzer, it can be a hooter, it can be some sort of alarm annunciator, it can be a motor if the motor is of low capacity. Even if you want to connect a very heavy motor, maybe a 5 HP motor, which requires a significant amount of current, and although it is a three-phase motor, now how we are going to connect it to the PLC, that might be a question to you. Don't bother yourself. You have got the concept of relays, solenoids available with you. So whenever we have got a heavy load, apply a relay for that, right? If you have a motor with three-phase connection and you want to apply only one output port to connect that motor, to connect to that motor, to control that motor, simply use a three-pole contactor. You give signal to the coil of the contactor, and accordingly you can handle the motor very easily with the help of a PLC. So these things you need to know. Remember that whenever outputs are concerned, these relay blocks, they are very important, because if you don't want to damage your PLC, you just allow a relay to work. Now it may so happen that your output device needs very fast switching, then relay may not serve the purpose. Under such circumstances, you need some faster devices. You may have to use an SCR at the output, you may have to use a solid state relay at the output if you are working at some hazardous condition, like that. Varieties are here also, just like in input devices. Now you see that the output ports of a PLC, what we have already seen, they are of relay type. So accordingly you can use the outputs. If you want to apply a relay type PLC card, be very sure what is the maximum current capacity of the relay, and be very sure that if your output asks very fast switching, then your relay type PLC is not going to suffice the purpose. Now you see, you can have these opto isolators at the output, you can have transistors at the output, you can have triacs at the output. For very fast application like pulse train output, you can use transistor output. For AC only application, you can use these triac outputs, like that. Now you see that the digital signal from the output channel of a PLC is employed to an actuator, and this actuator controls some process. Now you see, the term actuator is used for the device which transforms the electrical signal which we are getting from the PLC into some more powerful action, which then results in the control of the process. Again, here also the three common categories of outputs are discrete, register and analog. This register is a special type which can drive panel meters or displays. We will discuss this thing when we will be discussing shift register in PLCs. Next, the discrete outputs can be employed to use these pilot lights, solenoid valves or annunciator windows, that are lamp box. You can have analog output that can drive signals to variable speed drives, or you can use I2P converters and thus to control the flow control valves. This is the concept of analog output operation. You actually supply current, okay, the variable current from 4 to 20 milliampere current loop. So here you are applying that current to an I2P converter, and this I2P converter is controlling airflow through a commensurate valve, so that the air what is it is going to an air operated flow control valve. It can control the motion of the flow control valve, so that you can have ultimately have a control over the flow. If you have not gone through any flow control valve, I again ask you to come to the department of DTUKK. In the labs you will find flow control valve. Just get some idea about that. Okay, the flow control valves are like this. Here actually you connect the pipe through which the flow takes place, and here there is a diaphragm. when the air pressure is applied on the diaphragm either goes down, or if the air pressure is less, then the diaphragm goes up. The diaphragm is attached to a valve element which will either close the passage or open the passage. Accordingly, the flow control takes place. Now, as we change the current here, the pressure, that current is converted to pressure, and accordingly the pressure is applied to the air operated flow control valves. We will see some of the very common output devices. These are the pilot lamps. This is the alarm annunciator, which are very much used in process control industries. They are the relays, our best friends. This you can see is a contactor. You can see this is line 1, line 2, line 3, and terminal 1, terminal 2, terminal 3. That means that this contactor can be used for these three-phase applications. And here you can see this is the coil terminal. NO, it is written, this is the coil terminal. You can pass current through this coil, and accordingly this L will be connected to T terminal. L1 will be connected to T1, L2 will be connected to T2, and L3 will be connected to T3. Finally, you have got solenoid operated direction control valves, which are extensively used in hydraulic and pneumatic applications. Then you can use a color tower lamp, which are used as especially in manufacturing industries as well as in process industries, to show the status of some operation. There is a stepper motor driver. Such type of driver allows you to save the output ports of a PLC. Now normally you know that whenever we are driving a stepper motor, we need actually 4 wires, but such type of drivers that allow less number of wires to be connected from the PLC, so that you save number of outputs during certain operation. This is an I to P converter that I have already talked about. It converts current into proportional pressure. It is many times a debate whether we can consider VFD as output of the PLC, output device for a PLC. But you see, to my opinion, yes, it is. VFD, why it is a debate? Because VFDs can be independently connected with a motor to control the direction or the rotation of the motor. But when we want to control the motor through the PLC, then VFD has to be connected within the PLC, in between the PLC and the motor, so that the signals of the PLC that drives the VFD, and accordingly the VFD drives the motor. So in that sense, VFD can also be an output device for the PLC. So I will stop here with the discussion with the input and output devices, and in our next lecture we will start with the basic postulates of programming a PLC. Thank you.